At this point in the course, I've demonstrated all of the ASP.NET 5 features that you'll need in order to create a traditional web application that relies heavily on server-side rendering techniques and state management. Now, while this approach can be quite effective for a variety of scenarios, today's internet users tend to demand more out of their web experience. Now, 1 in every 5 people in the world has a cell phone. In the United States and other developed countries, this number is even higher. 3 out of 5 adults own a smartphone, and 2 out of 5 have a tablet or e-reader. Now, I'm not going to bother citing any specific surveys to prove this point, because all you really need to do is look around you to see that it's true. Mobile devices are already quite mainstream and are quickly becoming the primary device that many people use to access the internet. Now, historically, web developers have had a difficult time getting HTML to render in the same way on every browser due to different desktop PC browsers and the variety of different screen resolutions that may be running. The growing market for internet-enabled devices makes this problem exponentially more difficult, and the web development community is scrambling to find an effective solution. At this point, the most promising solution is a technique known as mobile first. As with many industry terms, there's no clear definition on the term mobile first. However, most people seem to agree that it means you should develop for the more limited mobile device form factors first, then build on top of that site to offer an enhanced version for other devices, such as desktop PCs with a bigger screen and more internet bandwidth. Now, the idea is that if it works great on a limited mobile device, it'll certainly work well on a more capable device. Since mobile first is more of a concept than an established design pattern, there are no clear rules for implementing it. Regardless, there are a few high-level techniques that can help you accomplish a mobile first implementation. First is responsive and adaptive design. This basically means delivering the same HTML to every browser, then optimizing the experience for the user's specific form factor and capabilities. Capabilities such as camera, GPS, or speech recognition. Next is conservative resource utilization. This is just a fancy word that means building lightweight pages that require as little CPU, graphical rendering, and network bandwidth as possible. Next is the lightweight UI services layer. Now, this is an architectural pattern that says that you should centralize your UI logic into a UI services layer and then expose that logic as an API that is easily and efficiently consumed by both desktop and mobile applications. Now, since responsive design techniques are primarily implemented on the client side via HTML and CSS, not on the server, ASP.NET does not have any features that will help you implement those techniques, which means I'm not going to be covering those topics in this course. Even still, I strongly encourage you to learn more about them by checking some of the other courses here in the lynda.com online video training library. I particularly recommend the Mobile Web Design and Development Fundamentals course. The last two, however, conservative resource utilization and UI services, are topics that server-side frameworks such as ASP.NET can certainly help out with, especially optimizing network bandwidth usage by avoiding full page rendering and only rendering parts of the page using AJAX and client-side rendering techniques. Over the next few videos, I'll show you how to offer users the ability to submit comments to our blog posts, and I'll do so with a focus on mobile-first design principles that will provide the best experience for all visitors to the site, regardless of whether they're browsing it from a small mobile device or even a large desktop computer monitor. Now, before I jump into the implementation, let's take a minute to discuss what I'm going to do and why I'm going to implement it the way I am. Now, let's assume that the blog we're building is going to be incredibly popular and that most posts will get a pretty significant number of comments posted to them. Now, if that's the case, it'd be a pretty big waste of our visitors' bandwidth and battery life to download and render a large number of comments for every post they view, especially since it's unlikely that they'd view every single comment. As such, we should be very considerate of that as we build out this new functionality. It will be far more responsible of us to provide users with the option to download and view the blog post comments on demand, and only downloading a handful of comments at a time. That way, users will only get the comments that they want to see and not waste time or bandwidth downloading more than that. And there are a few ways we could serve this dynamic content. One way is to retrieve the rendered HTML from the server via AJAX, That is, the server will generate only the HTML required to display the comment and nothing more. But an even more efficient way to implement this is for the server to send the raw data separate from the HTML template that it is rendered with. In other words, in order to render 100 comments, the client would retrieve the HTML template used to display the comments once, and then ask the server to send only the data for all the comments as opposed to the fully rendered HTML. Now enough chat. Let's move right on to the next videos in which I'll show you exactly how to implement both of these techniques and help you get that much closer to a mobile-first web application. Throughout this chapter, I'm going to show you a few different ways to avoid wasting users' bandwidth by sending them as little data as possible. And in this video, I'll start by showing you how to leverage Ajax and the partial view concept I showed earlier to only send the parts of the page that change when the user wants to see new content. Let's start by looking at the home page of the sample application for a good example of where this scenario might come in handy. As it stands, this page is designed to render the 3 most recent blog posts on the server and send them down to the client. And while I was editing this view in the previous videos, you may have gotten a glance at those hidden previous and next navigation buttons that I've placed in there with the intent of allowing users to see the next and previous group of blog posts right there on the home page. Currently, these links don't actually do anything, so let's start by implementing them using normal server-side rendering. I'll begin by editing the home page's index action to allow users to pass in a page number, page 1, 2, 3, etc. But before I implement paging, however, let me quickly add the blog data context class as a constructor parameter to be injected so that I can query live data from the database rather than the existing hard-coded post data. Then I'll create a link query to take this new page parameter into account, skipping the appropriate number of posts before taking the next couple to be shown to the user. While I'm at it, I'll add a couple of variables to the view bag to tell the navigation buttons which page is the next and previous page. Then I'll update the view to implement these buttons with some Razor code. Notice how I've used yet another HTML helper to determine the URL of the index controller action, including the page variable. Now that we have these changes in place, we can test it out by running the application and clicking the navigation buttons. And as you'd expect, what happens is a complete refresh of the entire page due to a full page navigation, which we can see by the URL changing with each click. This happens with each click regardless of the fact that it's only the content in the middle that's changing and none of the layout markup. So let's go ahead and change that. And it's actually simpler to implement than you might think. Since I'll need to add some jQuery code in order to implement this functionality, I'll start by creating a new JavaScript file in the www root folder, and I'll link that new file into the layout. Then I'll put my jQuery code into this new file. This little chunk of code simply says that whenever any links are clicked inside the navigation section of the blog post page, request that content via Ajax and replace the main content section of the blog post page with the results of this Ajax call. In other words, rather than a full page refresh, just refresh this one section. Although this is all the JavaScript I'll need in order to implement this functionality, as it stands, this won't work quite as expected. If I were to run the site right now and try this out, I'd actually see the whole page rendered inside of the main content area. That's because right now the controller action is using the view method to return the fully rendered view complete with layout. So in order for this approach to work, I need to do 2 things. First, I need to update my controller action to recognize when the request is an Ajax call. And when it is, return only the content in the view and not the layout as well. And second, I need to remove the layout property from my view because right now it will be set no matter whether the controller says to render the layout or not. Let's start with removing the layout property from the view because this is actually a really good chance to show you another Razor feature you may not have otherwise used. The issue we have here is how do we set the layout property on the view without that line of code? And the answer is the view start view. The view start view is a special view that gets run before every single view in the site. And it's in this page that you can put any common logic, such as setting the layout property for every page in the site. To implement the view start view, simply add a new file to your views folder named _viewstart.cshtml. Note that this time the underscore actually does matter in the Razor View name, so be sure to use it. Once you have this file in place, you can simply cut and paste the layout property from the index page and into this page. From this point on, the layout property will be set on every view without each view having to explicitly set the layout property itself. With that in place, let's move on to updating the controller action to look for AJAX requests. The first step is determining whether the request is an AJAX call or not. Since all AJAX calls add a special header, we can look for the value of this header in the request, and if it's there, we'll know that it's an AJAX request. Then, instead of calling the view method to return the full view with layout, we'll instead call the partial view method, which will only render the contents view that is defined and not render the layout as well. In other words, the partial view method will not run the view start logic like the full view method does. Note that we still need to pass in the array of posts as the model for the view to use. Now, when we switch back to the browser and refresh the page to try it out, everything works great. And there you have it. Partial page rendering using AJAX and server-side rendering with Razor. This is a great technique that you can use throughout your applications to avoid re-rendering the entire page when only a small portion of it needs to change. The biggest downside to this approach, however, is that even though the content within the markup is changing, we are still sending over the same HTML markup for every single post, which may be more than we actually need to. In the rest of this chapter, I'll show you how to save even more bandwidth by separating the HTML markup from the data you want to render and combining the two on the client rather than the server using a web API and client-side rendering techniques. In the previous video, I showed you how to avoid full page refreshes, only refreshing sections of your page by rendering views on the server and sending them to the client via AJAX. And while that approach does help save bandwidth by only transmitting the parts of the page that have changed, it's not the most optimized way of doing things, since technically it's only the data that's changing, and you still have to keep sending down the same HTML markup with every refresh. In this video, I'll show you how to expose your application data via a web API so that it is accessible by any number of clients, including browsers who can combine the data with templates on the client for a fully optimized approach. Throughout this course, I've been slowly implementing various aspects of the site, changing them from hard-coded HTML to real implementations. However, over the next few videos, I'm going to introduce a brand new feature, the ability for visitors to comment on a blog post, and I'll be doing this by introducing a web API. A web API is a server-side web service that exposes a lightweight interface and data structure with an emphasis on usability and the ability to be consumed by HTTP-based devices such as browsers. When it comes down to it, a web API is all about representing your data as a collection of entities, a set of endpoints or URLs that devices can easily interact with using standard HTTP verbs. Using this approach, each of the standard HTTP verbs, get, put, post, and delete, correspond to an action that you can take on an entity. For instance, a get indicates a request to retrieve an entity. A put indicates a request to update an existing entity. A post indicates a request to create a new entity. And finally, a delete indicates a request to remove an existing entity from the system. ASP.NET 5 makes it really easy to expose your model as a web API. In fact, web API endpoints are nothing but controller actions with an extra attribute or two on them. To demonstrate, let's create a new controller to expose our comments as a web API. Just like regular controllers, ASP.NET doesn't care where you place your web API controllers, but I like to put them in their own folder, separate from the regular controllers. So I'll start by creating a folder named API in the root of my site. Then I'll add the new controller by right-clicking the folder and selecting Add New Item, then choosing the Web API Controller class template. Since I'll be using this controller to work with comments, I'll call it Comments Controller. And when I'm done, I'll click Add to continue. Now let's take a look at what Visual Studio has generated for us. Notice how there's a method for each of the 4 HTTP verbs: get, put, post, and delete. And see how each of them is decorated with a corresponding attribute: HTTP GET, HTTP PUT, HTTP POST, and HTTP DELETE. A couple of these attributes include string values. This value is a URL route pattern, just like I showed in previous videos, only what's special about the way it's used here is that it's relative to the base route that is defined at the top of the class, API/controller in brackets. And although I didn't show it before, the controller placeholder in brackets indicates that ASP.NET should substitute this part of the URL with the name of the controller that the attribute is placed on. When the route attribute is placed at the controller level in this way, it means that this is the base route pattern for all of the controller actions in this class. In other words, when used in this class, the URL for the first get method would be /API/comments. And the URL for the second get method would be /API/comments/ID. It's important to note that this technique is not restricted to just creating web APIs. You can actually use it on any controller in your application. Now let's go ahead and try these new URLs out and see what happens. Go ahead and run the site and navigate to /API/comments. See how we got back an array of strings? If we jump back to the API controller, we can see that this means that we called the first get method. Likewise, if we add an ID to the end of the URL by going back to the browser and navigating to /API/comments/1, we only see one value, which means that we've successfully hit the second get method, whose route accepts an ID parameter at the end. The reason we're hitting these two get actions when we navigate to the URL in our browser is because every navigation event in the browser requests the resource with the HTTP GET verb. That means we won't be able to try out the other methods without using another tool, using an AJAX request, or creating an HTML form, and they're not actually implemented anyway. Move on to the next few videos, where I'll not only show you how to implement this controller to save and load comments to the database, but also consume the API via AJAX calls in the browser. In the previous video, I showed you how to add a new web API controller to an application. In this video, I'll show you how to use that controller to save and retrieve data in a database. I named the controller that I created in the previous video Comments Controller because I intended to use it to add and retrieve comments from the database. And as I showed in the Entity Framework videos, you need to have a class defined in order to use Entity Framework to interact with the database. So I'll start by creating the comment class in the models folder, and then I'll populate it with a few properties. Notice the post ID and post properties. It's no coincidence that these two properties are named similarly. Creating the post property of type post and the corresponding long property named post ID tells Entity Framework that this comment entity is related to the post entity. That means that Entity Framework will create the appropriate relationships when it creates the database, which will ensure that you won't be able to save a comment without a valid post ID value that refers to an ID of an existing post. Then, just like with our post entity, we have to add this entity to a data context in order to interact with it as a database table. To do this, we'll simply open the blog data context class and add a new DB set property named comments, this time using the comment type as the generic DB set parameter. Now we can begin using this updated data context to implement our comments controller. I'll start by injecting the blog data context class into the constructor of the controller, just like I did with the post controller in the dependency injection video. Then I can start referencing the context in my methods. We'll start with the first get method, the one that returns all of the comments. To implement this method, I can change the return type of the action to iQueryable of comment and just return the db.comments property directly. But think about this for a minute. Do we really want to expose the ability to get every single comment in the database? That could get a little out of hand once we get up to hundreds or even thousands of comments. Not to mention, the way that I intend to use this API is to work with comments for a specific post. That is, get all of the comments for the post, create a new comment on the post, etc. In other words, every single time I make a request to this API, I want to force the request to provide me with a post ID. And what better way to do that than to put it at the controller level? Just like I showed a few videos back, let's give this whole API a custom URL pattern that includes the post ID right in the URL. Something like API/post/post ID/comments. With this in place, every request must return a post ID, and the post ID parameter will be available for every controller action to use. That means I can update my get action to only return all of the comments that have the given post ID. Since I don't have a need right now to retrieve a single comment, I'll skip over the second get action, or you can actually just feel free to remove it entirely if you like. And I'll move right on to the post action that will allow clients to create a new comment using the HTTP post verb and posting the contents of the comment in the request. Then the comment is defined here as a complex type parameter on the action. Notice how the code that Visual Studio generated also prefixed the comment parameter with the from body attribute. This attribute tells ASP.NET to only consider the body of the HTTP request when it's attempting to populate the properties of the parameter. In other words, without this attribute in place, ASP.NET would map the value of the post ID placeholder in our URL pattern to the corresponding post ID property on the comment class. But because this attribute is in place, this mapping will not occur, and the only way that ASP.NET will automatically populate the post ID property is if it is explicitly set in the body of the request. Generally, that's a good thing and exactly what you want to happen. However, in this instance, we want to be very sure that the post ID on the URL matches the post ID of the comment that we're going to create. So, just like before, I'll add the post ID parameter to the post action, and I'll explicitly set the post ID on the comment myself. And just like when we created our blog post, I'll explicitly set the author and posted date properties as well, just to make sure they're always correct. With everything populated correctly, I can go ahead and save the comment to the database. Then I can return the updated comment right back to the client. That's all the code we need. But before we move on, let's quickly convert the whole method into an asynchronous method by adding the async await keywords and switching to the save changes async call on the data context. And that's it. Everything you need to create a web API that will let you add new comments and retrieve existing comments. I know, I haven't actually shown it working yet, but that's because we still need a way to execute an HTTP post call in order to create a comment before we can read it back out. The easiest way to do that is by submitting an HTML form post or initiating an AJAX call from the browser. So move right on to the next video where I'll show you how to consume this API via AJAX calls so you can finally get to see it in action. In the previous videos, I showed you how to expose your data as a set of web API endpoints that allow you to use standard HTTP verbs to create, retrieve, update, and even delete data in your database. In this video, I'll show you how to consume those web API endpoints to create and retrieve data via AJAX calls in the browser. Since writing AJAX calls with JavaScript is technically outside of the scope of this course, I'm going to start by copying a file that contains the JavaScript we'll need in this video. And I'll put that file into the www root folder of our application so that we can retrieve it from the browser. Now that we have this file, I'll quickly scroll through it to see that it's mostly just standard jQuery calls that read and write to the DOM. All except this part that actually interacts with the web API, all the way down at the bottom of the file in a JavaScript class called postCommentService. This class exposes two public methods, addComment and getComments, and each of these methods simply calls the real method, a call to jQuery's $AJAX method, to make the call to our web API. There are two important parts to this AJAX call. The first is how I'm reusing the same method and the same URL to implement two different operations, get and add. Though the URL is the same for both, I can differentiate between the two through the HTTP verb that I pass to the request, get to retrieve comments, and post to add a comment. The second part to notice is how I'm converting the object that I want to send into JSON first, and then using the content type parameter to tell jQuery to set the content type header of the request to application/JSON. That's in order for the web API to know how to deserialize the data I'm sending. In other words, deserialize it as JSON rather than XML or a regular array of form post values. Next, I'll need to add the HTML that goes with this jQuery code. To do that, I'll open up the post partial view and copy and paste the HTML from a temporary file as well. And finally, I'll add a reference to the new JavaScript file in our layout. And that's all we need to interact with our web API. A few lines of JavaScript and a simple HTML form. In most circumstances, we'd be ready to run the application to see this work. However, right now we're in an awkward situation because in order to implement the server-side piece in the previous video, we had to add the comment entity to the data context, and the database doesn't have a corresponding comments table. So, in order to proceed, we need to update the database somehow. The simplest option is to simply delete the database and recreate it. Now, obviously, with a database in a production environment, you're going to want to figure out the differences and update the schema in place rather than just delete and recreate the whole thing. However, since this is our local development database, this will work just fine for our purposes. To drop and recreate the database each time the application first runs, we'll add the following few lines to the startup class. Even though we never intend for this code to go into production, it's better safe than sorry. So the first line checks to make sure that the recreate database configuration setting is set, which I'll show you how to set in just a second. Then, once we've passed the check, we can request a reference to the blog data context by asking the application services object, which is the class that handles all of the dependency injection for the application. Then, once we have a reference to the blog data context, we can call the ensureDeleted method, which, as the name implies, will drop the database. We follow this call with a sleep command to give the database a few seconds to finish getting cleaned up. Then we can call the ensureCreated method to recreate the database again. To set the recreate database configuration setting, I'll open up the properties for the project. On the Debug tab is a list of environment variables that Visual Studio will pass in when the application runs. To add my variable to this list, I'll simply click Add, and then I'll type the name and the value for the variable in. With that in place, we can run the application and see it in action. Now, of course, since we just deleted the database, we'll have to create a new post to add comments to. And then we can start adding comments to our new post. And there you have it, using our new web API to interact with the data in our site via AJAX, so we can avoid refreshing the browser. At this point in the course, I've shown you almost everything you need to know in order to create a full-blown ASP.NET 5 application. Everything, that is, except for how to secure areas of your site to avoid just anyone coming in and creating blog posts and posting comments without having to log in first. In the next chapter, I'll show you how to lock your site up tight by securing your controller actions and offering users the ability to create user accounts and log into your application.